A colossal interstellar object has recently entered our solar system, capturing the attention of astronomers worldwide. Described as nearly 100 times larger and brighter than known celestial visitors, this mysterious traveler was first observed on September 12, 2025, by the SWAN instrument aboard the ESO spacecraft. Within 2 days, Australian comet observer Michael Mattiazzo captured an image that left experts astonished. Unlike typical comets, this object exhibits extraordinary properties. It is blazing toward the Sun with unprecedented intensity, dwarfing other recent sightings. Its tail stretches nearly 2.5 degrees across the night sky, 5 times the apparent width of the full moon, rendering even the tail of the recently discovered 3I Atlas nearly invisible by comparison. The enormous scale of this tail implies an immense release of material or energy, far beyond what conventional comets can produce. Some researchers speculate that this might represent a controlled phenomenon rather than natural solar outgassing. The International Astronomical Union officially named the object C-2025 R2 SWAN after its discovery instrument. Though initially labeled SWAN 25b, the formal designation has done little to quiet speculation. Unlike 3I Atlas, which originates near the galactic core, SWAN approaches from the Aquarius constellation, following a completely independent trajectory. 2 interstellar objects appearing within months and reaching perihelion almost simultaneously is extraordinary and perplexing. SWAN will approach the Sun at roughly 150 million kilometers, while 3I Atlas will follow shortly after at 203 million kilometers. By cosmic standards, this proximity is remarkably close. For a brief period in October 2025, both will vanish from view, hidden behind the Sun's glare. Astronomers are preparing for this solar blackout, as whatever occurs during this interval, be it gravitational interaction, acceleration, or fragmentation, could redefine our understanding of interstellar matter. The physical characteristics of these objects are equally astounding. 3I Atlas appears composed almost entirely of nickel, with energy emissions comparable to 50 nuclear power plants. Its tail behaves more like a precisely directed jet than a typical comet outflow. SWAN, however, surpasses even this. Its energy output is estimated at over 10,000 gigawatts, equivalent to the total energy consumption of humanity, and its surrounding plasma sheath seems to actively deflect the solar wind, hinting at advanced, possibly intelligent control. Spectroscopic analyses reveal exotic materials, including nickel-cobalt plasma mixed with carbon dioxide and carbon monoxide, suggesting processes far beyond natural cometary activity. Periodic variations in brightness indicate bursts of controlled propulsion, further reinforcing the theory that SWAN may not be a simple natural object, but an autonomous, engineered probe. Remarkably, SWAN's orbit suggests it returns approximately every 22,554 years. Its previous passage would have coincided with humanity's transition out of the last ice age, a period that saw the emergence of agriculture, monumental architecture, and early astronomical observation. Some theorists speculate that ancient civilizations may have recorded these periodic celestial events in structures such as the pyramids. The timing of modern interstellar arrivals, Oumuamua in 2017, 3I Atlas, and now SWAN R2, raises further questions. Could these objects represent a sequence of reconnaissance and command probes responding to humanity? AS broadcasted signals over decades? If so, this may constitute a form of first contact, though not through words or direct communication, but via autonomous machines monitoring and interacting with our solar system. As October approaches and these interstellar travelers pass behind the Sun, astronomers and the public alike will have to watch closely. Their reemergence could reveal interactions, trajectory changes, or even signs of intentional control. Whether these objects are natural or artificial, their presence challenges our understanding of the cosmos and our place within it. They may represent a cosmic test, a message, or a signal that the universe is far more active and deliberate than we have ever imagined. Humanity stands on the cusp of an extraordinary discovery. These two visitors, once considered mere comets, may be the first tangible evidence of technology far older and more advanced than our own. Observing them, questioning their nature, and sharing these insights may allow us to finally grasp a larger cosmic narrative that has been unfolding for millennia. As October draws near, the anticipation around these two cosmic visitors grows. SWAN and 3I Atlas are on converging paths that place them close to the Sun within mere days of each other. SWAN's closest approach, or perihelion, is expected to be around 150 million kilometers, essentially Earth's orbital distance. Only a few days later, 3I Atlas will follow at approximately 203 million kilometers. Though 50 million kilometers might seem vast, in cosmic terms it's like two speeding bullets brushing past one another. During this critical interval, both objects will disappear from view, hidden by the Sun's blinding glare. For weeks, Earth-based telescopes will be blind to their positions. This temporary blackout has astronomers preparing for every possibility. Gravitational interactions, near collisions, or even dramatic fragmentation. The events unfolding behind the Sun could drastically alter their courses or reveal phenomena entirely unexpected. Observations of these objects have already challenged conventional understanding. 3I Atlas exhibits unusual properties. Its core composition dominated by nickel rather than the typical iron-rich mix found in meteoritic material, and an energy output comparable to multiple nuclear power plants. Its tail doesn't disperse chaotically like ordinary comets, but instead forms a focused jet, suggesting active control. SWAN, by comparison, is on an even more extreme scale. Early data indicates a plasma envelope around its core that dynamically deflects solar particles, and its tail stretches across a width equivalent to 5 full moons. Periodic brightness pulses hint at controlled propulsion, perhaps nudging it along its trajectory deliberately. Spectroscopic studies reveal a mixture of nickel, cobalt, carbon dioxide, and carbon monoxide, elements and compounds unlikely to occur naturally together in this configuration. SWAN's core energy is estimated to exceed 10,000 gigawatts per second, an output that dwarfs human civilization's total consumption. Such power implies not just endurance across interstellar space, but the ability to operate with precision and resilience, potentially for thousands of years. The question arises, are these purely natural phenomena or engineered machines? Some researchers suggest 3I Atlas could be a reconnaissance probe, while SWAN represents a larger follow-up vessel designed to retrieve, analyze, or complete a mission. If correct, the cyclical return of SWAN, roughly every 22,554 years, would place it as an observer of humanity long before recorded history, witnessing the rise and fall of civilizations. Ancient monuments, including the Great Pyramid, Göbekli Tepe, and Stonehenge, may encode knowledge of such recurring events. Alignments with celestial objects hint at careful observations of the sky, possibly preserving awareness of these objects' appearances for future generations. This raises unsettling possibilities. These are not merely natural visitors, but participants in an interstellar cycle that humanity is only now beginning to recognize.